8.1, apply exponent properties. Involving products. All right, so just as like a rough example, okay, if you have a squared times a cubed, okay, this is a times a being multiplied by a times a times a, okay, and so that ends up being 5 total a's being multiplied, so this would be a to the 5th, okay. So that's just the general of where this stuff is coming from. But our goal is going to be that we don't ever have to write it like that, okay? Because we're going to have rules of exponents throughout this chapter that are going to make everything easier for you, okay? So the first one that we have is the product of powers property. And you don't need to know the name, you just need to know what you're doing with them. So, let A be a real number. So it can be any number, it doesn't matter. And let M and N be, whoa, that was not the word, be positive integers. Then a to the m times a to the n. So that would just be like if we were saying m was 2 and n was 3. It's the same thing of how it's written there. This is equal to a to the m plus n. Okay, so basically I could come back up here now and I could rewrite this from over here as a to the 2 plus 3. So when I'm multiplying two things that have the same base, so this down here, the a part is called the base. If they have the same base, I add their exponents together. Okay? So when multiplying two or more things with the same base, add their exponents together. So now this next one is the one that people tend to confuse these two, so I'm going to do my best to explain the difference in them and hopefully make it make sense for which one's which. The next one is called the power of a power property. So this stuff that I wrote up here, let a be a real number and m and n be positive integers, that all still applies. I'm not going to rewrite it. But if I have a to the m all raised to the n, so it looks like that, this is equal to a to the m times n. So I multiply their exponents. So this is like if I have one thing raised to a power raised to another power. Okay, then when that's a power to a power, we multiply. So if it's two things with the same base, we add their exponents. If it's a base being raised to something else, then we multiply. Okay, so let's see. To find a power to a power, multiply the exponents. And then the last one that's in this section is the power of a product. Property. So far we've had product of powers, we've had the power of a power, and now we have the power of a product. So that's why I said don't really worry about the names so much, because that's probably just going to end up confusing you if you try to think about the names like I think about the names, to the extent of I just wrote the title of them and that's about all I think about them. I'm just thinking about mathematically what are they doing, what's happening in here. So this one would be if I have something, again, all the stuff that I wrote up here, let A be a real number, M and N be positive integers, also applies down here. So this would be if I had A times B, and then all of that is being raised to the M. So I have two things that have different bases. Okay, so this could be like, obviously it's going to be a little bit of a bad example, but if I had like 2 times 3 raised to the M, okay, this is the same thing as A to the M times B to the M. So this power almost gets distributed on both of these things. You can think about it like distribution. I don't necessarily like to word it that way because it tends to be that people then start trying to distribute the numbers and do like M times A when it's actually A to the M and B to the M. Okay, so this is just a modification of this one for when there's multiple things in here. Okay, so this one, to find the power of a product, find the power of each factor and multiply. Alright, so jumping into some examples here, because the stuff's just easier to see the more that we work with it. And these should be problems that go a lot faster for you than the ones we've been doing, where it's been like all these steps. Like these are like very quick type things. So, simplify the expression, write your answer using exponents. Okay, so that means that they want things left in terms of exponents. If it just says to simplify, that means if I had something like 8 squared, you would tell me that that's what?
8 times 8.
Which is? 64. Okay, we should be able to just do those kinds of things. If it's something really big, obviously I don't expect you to do that, but those like little basic ones, like something squared, something cubed, we should be able to deal with. So these ones want us to write our answer using exponents. So I'm going to write this in the thing here. So simplify, write answers using exponents so that we know the difference in what we're doing. So number 4, we have 8 to the 5th times 8 squared. So when I have one like this, they have the same base and they're being multiplied. So when I have the same base, I add the exponent. So this is going to be 8 times 5 plus 2, which equals 8 to the 7th. Okay, and I want you writing this step out. Okay, I want to see what's happening because I want to make sure that I know that you know what you're doing. Okay, and that you're not just lucking out on the right answer. Okay, so for right now, in the homework, you need to be writing all these steps out. Number 6, 9 times 9 to the 5th. So this one's a little different because I don't see an exponent on this first 9, but is there one?
Yes.
What is it?
1.
There's an exponent of 1 here. So this would be 9 to the 1 plus 5, which is 9 to the 6th. 8. In parentheses, -6 raised to the 6th times another -6. Okay, and it's really important. If that negative's outside, then it just follows it through. But if it's inside, I've got to make sure I'm leaving it inside, because otherwise my final answer can be off if I was actually like multiplying them through. So, how would I write the next step of this one? What exponent's on this one? 1. So this is the same base. So -6 raised to what? 6 plus 1, which is, yes, -6 raised to the 7th. Notice I'm keeping those parentheses, because if I don't, I'm going to end up with the wrong final answer. So the base just follows it through. I'm never multiplying that stuff. The base follows through. It's just the exponents that are changing on these. Number 10. -3, which is in parentheses, squared, times -3 raised to the 11th times -3. So, what's different about this problem compared to the other one?
There's 3 of them.
There's 3 things being multiplied. So I do that -3. Then I add their exponents. So there's 1 there. So it's 2 plus 11 plus 1. So that's -3 raised to the 14th. Okay, and again, because this is a -3, I've got to make sure I keep it in that parentheses that was there to start with. Now, moving into the next type, 7 raised to the 4th, and then all of that is being cubed. So this is a power being raised to a power. So what does my rule tell me I need to do when I have a power to a power? Multiply the exponents. So this would be 7 to the 4 times 3, which is 7 raised to the 12th. Okay, I wouldn't expect you, if this was one that said to simplify the expression and it didn't say to leave it as exponents, I don't expect you to multiply 7 raised to the 12th. Okay? You would have a calculator for that. That's going to be some really, really big number. Okay? So, that would be one that you could leave. If it's something that we do know, like 8 squared, 3 cubed, something like that, then obviously we should be multiplying them. But this, you would just leave like that if it was in one of the later problems. 14. All right, I've got a bracket. Then I've got a -8 raised to the 9th. And then I've closed the bracket and it's being squared. Okay, now the reason that they've done a bracket and a parentheses is because that 8 is negative, and they want me to see that the -8 is being raised to the 9th, and then all of that is being raised to the 2nd. So I have a power to a power. So I multiply. So this is in parentheses. I was about to write -18. -8 raised to the 9 times 2. Which is what?
18.
-8 to the 18th. Next type, 16. I've got 17 times 16 raised to the 4th. So this is, I don't even remember what the title of it was. Anyways, when I have 2 things being multiplied and raised to the power goes on each of them. Okay, so this becomes 17 to the 4th times 16 to the 4th. And that's all that those ones have to have done to them.
Okay, so it's just very easy.
That's why I said I think y'all are going to like this stuff better.
Oh my gosh. I love this lesson. I'm doing that one.
18. In parentheses, and then I've got another parentheses with a -14 in it, times 22, and then it's all being raised to the 5th. What would I do with this one?
The same thing we did with the last one.
Okay, I'm distributing it now. Again, just to keep in mind, that's the easiest way to explain what's happening, but remember, it's the exponents being distributed, not like 5 times those things. So I've got negative 14 raised to the 5th times 22 raised to the 5th. Notice I kept the parentheses around that negative 14, but the other one is just 22 raised to the 5th, like that.
So you only keep the parentheses around it if it's a negative?
Yeah. Or if it starts you with a parentheses around like an individual number, there's probably a reason for it. More so if it's like a variable, but yeah. Typically it's just going to end up on the negative ones. All right, the next ones just say to simplify. Okay, that means that we're going to take them as far as possible. And these ones are going to have variables in them. All the ones we've done so far have just had numbers. So 20 y to the 9th times y. So this works the exact same way, even though it's variables. I've got a 1 here. So what would this be?
Y to the 9 plus 1.
Y to the 9 plus 1, which is y to the 10. 22. A to the 4th times a cubed times a to the 10th. What do I do with this one? Add the exponents because they have the same base. So this is a to the 4 plus 3 plus 10. And I get
A to the 17.
a to the 17.
That was a real number.
So then what is 8?
24. Y to the 4th in parentheses raised to the 6th.
Got multiplied, Jeff.
We multiply them. So this is y to the 4. Yep, 6 times 4, 4 times 6, however you want to write it. So that's y to the 24.
Easy.
Bryn, there's nothing you jinx about this.
There's nothing to jinx about.
That's less than
That's
that.
less.
You say that now.
See?
What do you mean you say that now?
See? Next lesson, you just put brackets.
Wait for my graphic.
What's different about this problem?
Which brackets?
There's
There's a D plus 9.
Yeah, so everything else has just been like a number or a variable raised to a power, then raised to a power. But this one is in parentheses d plus 9. So Abby, to your question you asked a minute ago, this is somewhere else I would keep those parentheses. Okay, so there's no negatives here, but I would keep the parentheses. This is still a power raised to a power. Are we ready for a quiz? Okay, let's pay attention then. So I keep this stuff in parentheses. So d plus 9, that just all stays together as one unit. And then I've got 7 times 3. So in parentheses, d plus 9 raised to the 21. So same thing, but don't start trying to, I can't do this. This 21 doesn't go on D and on 9 because these are being added. Okay, so this process that I used up here with 16 and 18, that only works because these were being multiplied. Okay, so make sure you notice that. That's the difference in the like 18 and 26. This one's being added, these were being multiplied. Okay? (28) Negative, then a parentheses 5x raised to the 2. Any ideas about this one?
Multiply by negative. I'm gonna guess multiply by negative.
Maybe just leave it alone. Yeah, it's perfect the way it is. Exactly.
Okay, ignore the negative that's out here. What would I do if that was the only thing I had?
Just add.
Just leave it.
Yes. Okay. I would put this as 5 squared and x squared. Okay? All that's happening with this negative outside is a negative's going to sit right there at the end.
Oh.
Okay? Now, this one is just simplify. It doesn't say to leave it in terms of exponents. So, if I have a number that's being raised to a power, I should be going all the way through with that. What is 5 squared? 25. So this becomes negative 25x squared. It would have been a different answer if the negative was inside the parentheses. It was outside, so I left it alone. Okay, if you want to think about it, leave it like that until you get to your final answer. Okay? $30. In parentheses, 5 times p times q raised to the 3. What do I do at this one?
Distribute.
Okay, so I end up with 5 to the 3, p to the 3, q to the 3. I'm not done yet. I have 5 cubed, so what's 5 times 5? 25 times 5 is? 125. 125 p cubed, q cubed. Okay, if you ever get stuck, once you have like squared 5 and you have to keep going, think about it in terms of money. It's kind of helpful. $32. Negative, or this is in parentheses, negative 8m. The m is raised to the 4th. Close the parentheses. All of that is squared. Times m cubed.
That can't be that hard, can it?
All right, so there's 2 different ways we can approach this problem. I can look at this negative as being by itself, the 8 by itself, and the m to the 4th by itself. Or I can add in my own set of parentheses here and treat that as negative 8, okay? Which is what I typically would do, okay? I would treat it as negative 8. Now, what would you do? Ignore this times m cubed over here. What would you do if all we had was this piece right here? How would we write it?
Oh, wait.
Negative 8 what? Squared. Then what?
M to the 4th. To the 8th.
To the 8th, okay? So the 4 times 2. So I'm gonna bracket this off because there's a lot happening. Times m cubed. I'm just keeping that part with me. Now, what is negative 8 squared?
64.
Yes, positive 64. That negative is also being squared. If a negative is raised to an even power, it becomes positive. If it's raised to an odd power, it stays negative. So this would be 64. What is m to the 4 times 2? M to the 8th. And then times m cubed. Now what do I do?
You have to
Add the exponent. So this is 64 to the m, or 64m to the 8 plus 3, which gives me 64m to the 11th. Okay? So the process stays the same. There's just more that I've got to be watching out for as we go through with these problems. Obviously, they get harder. Yes.
So if negative 8 squared is 64, oh wait, never mind. Is that, never mind, I got it, I figured it out.
All right, 34. In parentheses, negative 20 x cubed, all of that is squared, times negative x to the 7th. Okay, so again, I'm going to put my own parentheses around negative 20 so that I pay attention to that negative sign. So we take negative 20 and I square it. Then what happens here?
Comes to 6.
And then
X to the 3 times 2. I'm going to bracket all that again. And then times negative x to the 7th. Now, what is negative 20 squared?
400.
400.
Positive 400. What is x to the 3 times 2?
X to the 5.
X.
X to the 5th? Nope.
Wait. X to the 6.
X to the 6th,
Yeah, right.
3 times 2.
No.
And then all of this is times negative x to the 7th. Okay? So I can take this negative sign and put it out front. So that's going to be negative 400. Then what happens with these things that are being multiplied that have the same base?
Come
Add
together.
Combine.
Add their exponents. So I have x to the 6 plus 7. And so this gives me negative 400 x to the 13th.
Plus you.
Wait, aren't they different? So they have one of them's a negative.
Wait, yeah.
What's the question?
Wouldn't the bases be different because one of them's a negative?
Nope.
Alright.
Just like negative 1 times. It's just like 400 times negative 1 times. So 1/2 y to the 5th cubed, all that's cubed, times 2y squared, all raised to the 4th.
Distribute.
Yep, do that on both of them. So this one's a little bit different because I now have 1/2 being cubed, which is another rule that wasn't even in this section we're going to talk about. Then I've got y to the 5 times 3. Then over here, I'm going to put a big parentheses around that, I've got 2 raised to the 4th times y to the 2 times 8. Times 4. Saying what it's equal to. So, if I have a fraction, and I'm sure this will come in a later section, it wasn't in this one. This gets put on both of these pieces here. So this will be the same thing as 1 cubed over 2 cubed. Okay? So then this becomes y to the 15th. 2 to the 4th is what?
16. No.
Yep.
Oh.
And then this is y to the 8th. So this fraction here, 1 cubed is what?
It's 1/8.
Okay, 1 cubed is 1. Over 2 cubed is
8.
8. So this is 1 over 8. Y to the 15th times 16 y to the 8th. What do you think I need to do now?
Add that
Add the
to-
8. Add the y's.
Add their exponents. So I've got y to the 15 plus 8. What about this 1/8 and 16?
You can times it.
What happens when I do that?
You're gonna get like 2.
Gives me 2. So this stuff cancels here. So then now my final answer, 2y to the, what is that, 23? And that would be my final answer.
Yeah, it's not so easy anymore.
Oh, I wonder who jinxed it.
You just point to a wall.
Abby jinxed it.
You just point to a wall. It was Abby.
Abby's been quiet this whole time.
38. Negative 10n squared, so all that's in parentheses being squared, times negative 4n cubed, and all of that is cubed.
Distribute.
So I would take and put these negative numbers in a parentheses so that I'm paying attention to that. So I've got negative 10 squared and n squared. Then I've got over here negative 4 cubed. And then what happens over here?
They times.
They're multiplied. I'm just going to write this as n to the 9th. We've been doing this for a while now. So now what?
Then we actually do the exponents. Or like the normal
Can do the
numbers.
n and the
Okay,
n.
so what does that give me? What's negative 10 squared?
100.
100. I've got n squared here. What's negative 4 cubed?
64. Negative 64.
Negative 64. Okay, so this is a negative number raised to an odd power. It stays negative. And then times into the ninth. At this point, what happens?
And you're gonna add the exponents and like. Add
What's 100 times negative 64?
100 times negative 64.
I need to
Negative
calculate.
6,400.
What the?
Oh my god.
You just add zeros.
There.
You just add zeros.
Yeah.
Yep, however many zeros are over here, since this is just a 1, we just take the 2 zeros and put them on whatever number that is. So this is negative 6,400 into the 11th.
Stop it. You're gonna make it worse.
Oh, video. I need you to shut
Number
up.
57.
And if I don't,
Alright, I want you to try this last one on your own.
40. The big number 40. I hope. If it's 42, I'll be a little bit mad.
I already know.
48.
Don't.
They say 42.
You should make it
I mean,
an
yeah, fair
odd
point.
number so we can put on our homework.
You know when talking to
Negative times negative xy squared z cubed raised to the 5th times x to the 4th y z all of that squared.
Oh.
What the fuck? You even go.
Get this away from me!
What the fart?
I don't want to. Not even dog.
It's the same thing we've done. It's just bigger in all variables. Okay? So there's nothing that you're actually multiplying, okay? It's all just variables.
I forget what the
Those aren't even numbers
X,
anymore.
Y, and Z are.
You were never
I mean, no. 2, 3, 5, 1, 2. Okay.
I think
Is this stuff gonna be
I give
like
up.
this big of a problem on our quiz?
Could be.
Love that song.
Wait, actually not that bad.
Oh, video? Actually,
I'm a punch you.
wait, this actually isn't that bad. You're
Yeah,
wrong.
that's just
Jonathan,
what I said.
shh. I'm trying to focus. Damn. Look, bro. Why haven't you started yet? Why are you looking at me like that?
I got mine back. I actually got it.
Just take me down, God. I did nothing, Grace. I think I got it too. Oh, what is your peak hair, Grace? I got it.
Like that one piece. I know you're thinking of that one piece.
Wait, that can't be right.
You need to get out of your face.
Grace, what are you?
You've seen that one video.
Yeah, I think the word keep breaking.
Oh, shit,
that's a 5, not a 3. That's a 5.
Yeah.
That's one mistake.
You can't even see your own handwriting, dude. You're failing.
Okay, I think you're ready for the answer.
No, I'm not ready.
I'm not ready.
I haven't even.
Okay, I think I got
What?
it.
Albert Einstein's like chocolate. That's what it looks like, bro. It's like you're brainstorming how to make a black hole.
Like you have one.
Yeah.
I mean, happy
No.
birthday.
No.
Happy birthday.
Okay, so I hate when people just give me random
Happy birthday.
That's my other sheet.
Why do you need? Why do you
Happy
see?
Why
birthday.
can't I just
That's my
like,
piece
give
of
out
paper.
pens?
Oh, it is?
That's a
Yeah.
good idea.
Happy birthday.
Start giving out pencils.
Honestly,
No,
no, Sam
here
would
you go.
love this class
Like
for
I need
communists.
it.
Sam
Yes.
would love this class for communists. Then he gets all the pencils he
Sam,
needs.
you can't use that.
Oh, Sam.
What is
I
this?
thought-
Got
I
it.
thought this was
Let
my
me
homework
see.
first.
I don't know what I'm doing.
Honestly, it's probably wrong, but I think it's close.
Stop showing off my pencils.
All right, I'm gonna go over it. Let's see. What did we get?
I got X13, Y12, Z17.
I
Bro, I got X 14,
Yeah,
Y
same.
12, and Z 30.
Y 20, Z 30.
I got X 13,
Hey,
Y
that's what I got.
X 13,
No,
Y
yeah.
12, Z 17.
Can you all slow
Yeah,
down?
That's what I got.
No.
That's correct.
Yes!
You copied off Jonathan.
No, I didn't.
You were like,
All right.
You wanna see my math?
Listen. I'm going to talk through it really quick. All right, this negative outside, I brought it down with me. I treated this negative x as one whole unit, okay? So it's negative x to the 5th. Then I've got that 5 times 2, so y to the 5 times 2, z to the 3 times 5. Then in the next one, x to the 4 times 2, y to the 2, z to the 2, okay? Now, that negative out front followed me down. A negative value, okay, so negative x raised to the 5th, that stays negative. So it's negative x to the 5th, y to the 10, z to the 15, then, and the other one, x to the 8, and then the y squared, z squared just came down. Now I have a negative times a negative, so I made it positive. Then I had x to the 5 plus 8, because that has the same base and they're being multiplied, so I add their exponents. Y to the 10 plus 2 for the same reason, z to the 15 plus 2, and so I ultimately end up with x to the 13, y to the 12, z to the 17.
That was a lot.
It is a lot, but you need to be able to do stuff like this, okay, because it's going to help you later on. So your problems are 3 through 37 odd. I know it seems like a lot, but it does not take that long to do these problems. Okay?
Especially the early ones.
And, yeah, the early ones really shouldn't take you that long. Number 49 is one like this, but it also has numbers. Okay? But it's not hard numbers. They're numbers that you should be able to multiply relatively easy to do.
Okay, video, I just
The last two video was somehow difficult.
Oh, because I just realized all you do is multiply and then combine my terms.